We're now going to look at oxidation states. This is another part of the topic. So let's just recap a little bit on oxidation and reduction. So these are the three ways oxidation and reduction can happen. Oxidation is gain in oxygen, loss in hydrogen, or loss in electrons, while reduction is loss in oxygen, gain of hydrogen, and gain of electrons. So we're going to look at the oxidation state. And this is a way to know whether oxidation or reduction has happened, a fourth definition of oxidation and reduction. So oxidation is increase in oxidation state and reduction is decrease in oxidation state. But let's look at how we find oxidation state. Now, what is oxidation state? It is the apparent charge of an atom in a free element, a molecule or an ion. It is a charge that an atom or an element would have if it exists as a simple ion in a compound, even if it is covalently bonded. What does that mean? Actually, oxidation state is not something that's real. It is assigned, actually. And it is actually hypothetical. It is a charge that we are assuming an atom would have if its bonding was entirely ionic, even if that compound would not form an ionic bond. So we are assuming that it is entirely ionic. So it is hypothetical. It's not something that actually exists. And the oxidation state is always written with a charge before the number. So we're always going to have oxidation state +1, +2, -1, -2, things like that. And oxidation state can also be 0. So let's look at the rules or the guidelines for assigning oxidation state. And you have to know these guidelines. Now, the oxidation state of an atom in a free uncombined element. Uncombined element means it's still in its elemental state. For example, chlorine, it's Cl2. It's combined with chlorine, but it is still in the elemental state. Oxygen, O2, nitrogen, N2, copper, phosphorus, sulfur. Phosphorus actually exists as P4. It's actually P4. And sulfur exists as S8. So in all of these elements, uncombined, so it's not combined with any other element, it is still in its elemental state. So all of these oxidation state would be 0. So if it is an element uncombined, oxidation state is 0. Second rule, algebraic sum of all oxidation state in a compound must add up to 0. So for example, if I have H2O, oxidation state of hydrogen plus, so 2 times oxidation state of hydrogen because we have 2 hydrogen, plus oxidation state of oxygen must add up to be equal to 0. So in any compound, oxidation state adds up to be 0. Third rule, for ionic compounds, oxidation state of each element is equal to the charge on the ion. For example, NaCl. We know that NaCl is an ionic compound. It is formed by Na plus and Cl minus. So in that compound, oxidation state of Na is +1 and oxidation state of Cl is -1. Okay, because it is an ionic compound, oxidation state of each element is equal to the charge on that ion. For covalent compounds, we are going to assume that the compound is ionic, where the more electronegative ion, the more electronegative atom is forming the negative ion. For example, I take HCl, so this is covalent, but Cl is more electronegative than H. So we're going to assume that it is Cl minus. Therefore, this is going to be H plus. Therefore, oxidation state of H is +1 and oxidation state of Cl is -1. Let's look now at oxidation state of simple ions. For simple ions, the oxidation state is equal to the charge of the ion. So K plus oxidation state +1, Cu2 plus +2, Al3 plus +3, and so on. So the oxidation state is equal to the, and always remember you put the charge before the number. Another rule, group 1 compounds, group 1 metal compounds are always assigned oxidation state of +1. So for example, NaCl, Na will always be +1. Cs, cesium, group 1, oxidation state +1. Lithium, group 1, oxidation state +1. Right? Next one. The alkali earth metals, these are the group 2 metals. Group 2 metals, along with zinc, cadmium, they are always assigned oxidation state +2. So magnesium group 2 +2, calcium group 2 +2, zinc group 2 +2. Now these are the basic rules, and we're going to use these basic rules to find oxidation state of elements that we don't know. Let's take one example. Let's take this one, lithium oxide. So Li2O. So we know that lithium is in group 1 and has oxidation state +1. Let's try to find the oxidation state of oxygen. Let's say we don't know this. Okay, so we have 2 lithium plus 1 oxygen, right? When you add the oxidation state of all of them, it should give you 0 because it is a compound. If you look at the rule here, algebraic sum of all oxidation state in a compound must add up to be 0. So 2 times oxidation state of lithium +1. Oxidation state of oxygen, I don't know, I'm going to put it X. This adds up to be 0. So X would be -2. Therefore, oxidation state of oxygen is -2. Actually, oxidation state of oxygen in most compounds is -2. Let's try another compound, CaCl2. So Ca is a group 2 element, therefore oxidation state +2. Cl, we don't know, let's put it X. So oxidation state of calcium plus 2 times oxidation state of Cl, because there's 2 Cl here, so 2 times X should give you 0. So this is +2 plus 2x is equal to 0. So 2x is -2, x is -1. So this is oxidation state of Cl. So similarly, I'm going to give you a few exercises just so that you can practice finding oxidation state in a compound. These are the basic rules. Like I said, everything that's coming up will involve exceptions.